I'm Dr. Kingston, a product of Samajesu Easy World. Join Samajesu Easy World today and be proud of what your tomorrow may be. Thank you and remain blessed.
Wait a minute, have you heard about Sir Majesty Easy World? Well, I'm a subscriber to at Sir Majesty Easy World on YouTube, and I'm a student at University of Camerino, Italy. Sir Majesty made science so easy for me, and it took away the fear I had on chemistry and biology. Distance is not the barrier. Guys, you have to join the Easy World today at www.easyworldscience.com and on YouTube at Sir Majesty Easy World. Bye. Thank me later.
Okay, here I'm going to carry out a titration using double indicator, this is the titration actually between hydrochloric acid and the mixture of this is hydrochloric acid, and this is a mixture of sodium carbonate and sodium hydrogen carbonate. Normally, we need to use phenolphthalein indicator first, and then followed by methyl orange. The endpoints for the two are not the same. We have a phenolphthalein endpoint, then the methyl orange endpoint. But in real sense, when you mix sodium carbonate with sodium hydrogen carbonate, actually the two do not coexist. I have my own findings, but this is normal thing we assume to happen. But from my research, I'm not in the support of the idea that when you mix sodium carbonate and sodium hydrogen carbonate, that the hydrogen carbonate remains unchanged in that mixture. No, rather it should be a different argument on a separate video altogether. Just stay subscribed so that you get. But here I will just give you the steps on how to do the titration. Here I filled this to 0, of course. Then I said I will use phenolphthalein first. Then I'll get my first endpoint with phenolphthalein and then add methyl orange again and continue till I get, so you have a double table like you see there on the screen if you are required to use double indicator. If you are using methyl orange, the equation of the reaction will just be HCl plus Na2CO3 to give you, that is if you are using phenolphthalein, because the endpoint there will just form the acid salt, sodium bicarbonate again. But on complete neutralization, this one will ensure complete neutralization. But if they ask you the two, the most suitable indicator in the titration between the hydrochloric acid and the mixture of sodium carbonate and the sodium hydrogen carbonate, the suitable indicator is methyl orange. Because if you use methyl orange, you get the actual endpoint straight without stopping at halfway. And in that my argument, you now see why we say that methyl orange is not suitable when you are titrating a strong acid against a weak base. So that is why we don't use phenolphthalein, rather methyl orange is the ideal. In acid triazocarbonate form, methyl orange is the ideal and not actually phenolphthalein. This titration is it will prove to you why that is true. Although in my separate video where I will show to interested scientists that this assumption that when you mix sodium carbonate and sodium hydrogen carbonate that they coexist, no, there's some sort of chemical reaction taking place there such that one will no longer be existing, or rather the concentrations might change. But for the sake of doubt, let's just handle this double indicator titration. Now I want to restore this to 0. Okay, that's 0. Here is my base. I've tapped out some. So here is 25 ml volumetric pipette. Okay. The concentration of the acid I'm using is 0.1 mole or 0.11 mole. That's the concentration of the HCl. So you can now use the endpoint to calculate the concentration of this base. Okay. So I'm using phenolphthalein first. Add it enough. Yeah. So when it becomes colorless, I will stop and take the reading, then add another indicator, which is methyl orange, and continue. My initial here is 0.00. See, it's colorless now. This is position. Okay. Requires a little drop. So we have gotten the endpoint we have here is yeah, this is colorless now. We have this is 10.6. This is 10.6 with phenolphthalein, 10.6. Then to proceed further, I will now add the second indicator, methyl orange. See, it's yellow. I will now continue the titration until it becomes orange. I'll take the correct reading. Remember, we stopped at 10.6. That's phenolphthalein endpoint. We are there. Slightly. These two colors are not the same. Yeah. Confirm. So this is the methyl orange indicator endpoint, and here it's giving me 34.5. So this is 34.5, and the other one was 10.5 for the phenolphthalein. The phenolphthalein gave us 10.5, whereas that of methyl orange took it down to 34.5.
Hi, my name is Cheryl.
And I'm Jennifer.
Guess what? There's a channel called Majesty Easy World Science.
And you know the best part?
Mm-hmm.
It makes science so easy. Wow.
It makes science easy, simplified, and very, very fun.
Guess what? Rocket science ain't rocket science anymore.
It's now ABC.
Like if you did science your entire life.
Another thing about Majesty Easy World Science channel is that he makes available laboratory equipment and reagents.
Guess the best part? If chemistry has been hard for you, he does tutorials.
And another thing is, when you order for these things, they are high quality and they are also cheap and affordable for anybody.
If you want to order, just look at the number below the screen.
And don't forget to subscribe and hit the little notification button down below.
Don't forget to share, of course, obviously, there's love in sharing.
Thank you! We'll see you there.
So you will have two tables. If you are required to use these two, you have a table for phenolphthalein, final, initial. For phenolphthalein, my initial was 0, then my final was 10.5 or 10.6, yes. Then for the for methyl orange, in real sense, because the whole thing there was an acid added to it before. So that acid even amounts to the same indicator. So we take that for the methyl orange, it is still 0. From 0 is the initial, then the final was 34.5. That's it. So you still do your substitution, which means under methyl orange indicator, it consumed extra. You say 10.6. You say 34.5 minus 10.6, which is approximately getting to 20, just 19 point something. So you see, it takes more acid, and which shows that the most reliable indicator to be used should be actually this methyl orange and not phenolphthalein indicator. Not just because this is a mixture of sodium carbonate and sodium hydrogen carbonate. Like I told you in a separate video, you will see, you just get my argument and my research, what my findings proves. It's somehow based on what majority know in this double titration, especially the one involving HCl and sodium hydrogen carbonate mixed with sodium carbonate. So now I told you the concentration, the molarity of this is 0.11 mole. Then you have seen the volume. Use the endpoint for the methyl orange to calculate. You get the concentration required. But if the examiner wants you to use methyl orange, you know what will happen. The only thing there is that the methyl orange will take the neutralization to formation of more acid salt, which is sodium hydrogen triazocarbonate 4. Then while this one will take it to complete neutralization, will neutralize the sodium hydrogen triazocarbonate 4 to normal salt or sodium, actually to form normal salt, to form sodium chloride, then with water and CO2. But when you add phenolphthalein, it stops indicating when sodium hydrogen triazocarbonate 4 forms, because it is an acid salt, and of course it should be colorless under that medium. So this is it for the double indicator titration as assumed. But watch my discoveries concerning any titration involving dilute acid and trioxocarbonate 4, mainly reaction between the HCl or HNO3 and the triazocarbonate 4. You see what happens there, and the real chemistry of, I told you there is sort of reaction taking place when you mix sodium triazocarbonate 4 and sodium hydrogen triazocarbonate 4. From my findings, it's not true that the hydrogen carbonates and the sodium carbonate do not coexist. There's a kind of reaction that takes place to give us a new, not even a new product, but one product is converted to the other. Yeah, from my findings. So this is Her Majesty's Awesome, of course. Subscribe and share my videos. Nice having you. God bless you. You can come on board if you need more guide and more instructions on how to do these things. You call me or you chat me on WhatsApp with the number you see there on the screen. Remember, Majesty, God bless you. You cannot do without you. Bye for now.